Hi everyone, find functional dependency preserving or not for the given decomposition. Means here they have given a relation R with set of attributes A, B, C, and also they have given the set of functional dependencies which are possible for the relation R and the set of decomposition relations which are possible on the relation R. Finally, we need to define whether the FDs are preserved over these sub-relations or not. Guys, you know how to solve whether it is FD preserving or not, right? So for this you can go to the previous video so that you can get clear idea how to solve it, right? So basically if you are going to have relation R, it may have set of FDs as F1, and if you are going to have relation R2, it may have set of FDs as F2, and so on. If you are going to have relation Rm, it is going to have set of FDs as Fm, right? Finally, you need to find the closure for this, and if this closure is equal to the actual relation FDs, I can call it as FD preserving, right? And for this we have seen an example also, right? So this is one more example, so try to do it, right? So let me take a relation AB. You need to define which are additional attributes which are possible. So try to find out the FDs which are possible with A, right? So for that we are going to find out A closure. From A you will get B, from B you will get C. But anyway C is not in our relation, so we can able to simply wiped out. And A is a kind of a trivial functional dependency generated, so we can able to wiped out. So we are going to get an FD called A determines B. Similarly, we need to find out the FDs which are possible with B. So for that you are going to get B, from B you can get C, from C you can get A. A is possible, C is not in our relation, and B is trivial one. So B determines A is possible. Okay, fine. Next we have to find out two level attributes closure. So AB closure is what? You are going to get AB only, which is trivial. From B you will get C, which is not in our relation, right? So AB closure is not going to determine any new additional functional dependencies for the relation AB. So the list of FDs possible for AB relation R, I can call it as F1. So A determines B and B determines A, right? Next, similarly, try to find out the set of FDs which are possible for the relation BC, right? So if you are able to find out B closure, you are going to get B determines C. I mean, you can able to find out various things, you will get the FD as B determines C. Similarly, try to find out C closure, you are going to get C determines B. So the set of FDs which are possible for with the C is C determines B. Similarly, if you are able to find out BC closure, you will get only BC, so it is not possible. So the set of FDs possible for the relation BC or F2, I can say that, and the FDs I am writing here, B determines C and C determines B. Now you have to define whether the FD preserving or not. For that reason, what you have to do, you can just simply take one FD from the actual FDs. A determines B. Is it possible from the F1? Yes. Next, B determines C. Check. B determines C is possible. C determines A. Any one of the set of FDs are possible? Directly it is not. But if you are going to take these two combination, that is C determines B, B determines A, you are going to get C determines A, meaning that according to transitive property, we can able to get C determines A also. So I can say that this decomposition is FD preserving. I hope you understood clearly. Thank you.